welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this problem. We are given two matrices, which is A, x, 4, 3 minus x, and we have for matrix B as well. So they request us to find the integral of the determinant of A over the determinant of B, right? So first of all, we have to apply the principle of finding the determinant of matrix. This is a matrix 2 by 2 and this is a matrix 2 by 2. Okay, because there is 2 line and 2 column. To find the determinant, we find the product of the main diagonal, which is this one. Multiplying x times x will be x squared minus 3x, and multiplying this will be minus 12, and this is negative because of the negative from the formula will be plus 4x, okay, over. Now we come here on this side, the same approach. We have x cubed plus 9x squared minus, now we multiply here will be minus 9x squared and minus 27 dx. Okay, so that means we can go further. We have x squared minus 3x plus 4x, it's equal to plus x minus 12 over x cubed minus 27 dx, because they are cancelled out since they're symmetric. We can transform this sum into product. Since it's a quadratic function, we can find two numbers that are multiplying is negative 12 and they add up to 1. So obviously it's plus 4 and minus 3. If we multiply those big, 27 is 3 to the power 3, so we can apply the difference of 2 cubed. So will be x minus 3 times x squared plus 3x plus 9 dx. So these two, they can be simplified and we are left with integral of x plus 4 over x squared plus 3x plus 9 dx. Okay, for this particular case now, when we have this type of integral whereby the numerator is a first degree function and denominator is quadratic function, we have to transform the numerator in terms of a first degree function so that when we derivate the denominator we get this expression. Okay, so we know that the derivative of the denominator is 2x plus 3, so we have to have 2x plus 3 on top. So since we don't have this 2x plus 3, first we're going to say it's 1 over 2, the 2 that we're looking for, so it simplifies. But the thing is, here we have 4, so we can put 8. So 2 divided by 2 is x, and 8 divided by 2 is 4. So it's now fine, x squared plus 3x plus 9 dx. But the derivative of this denominator, it's not 8. It will be 2x plus 3. So we have 8. We can split it into 1 over 2 integral of 2x plus 3 over x squared plus 3x plus 9 dx. If we take 3 from 8, we left with 5. So that will be plus 5 over 2 integral dx over x squared plus 3x plus 9. Okay. So the derivative of the denominator is the numerator. Derivative of the denominator is the numerator over x squared plus 3x plus 9. Okay, so this is equivalent of the integral dx over x, which is lim. For this one, plus 5 over 2, we can transform this into quadratic perfect square. So x squared plus 2 times 3 over 2x plus 9 over 4 minus 9 over 4 plus 9. Why that? Because to transform it into perfect square, we have to have the 2 of the formula, which we don't have. So that's why we implemented 2, and we can simplify, goes back there. And for us to have this term squared, which is 9 over 4, we have to take it out so that it goes back to 9. Okay, for the first one we have 1 over 2 lim of x squared plus 3x plus 9 plus 5 over 2. For this one, we can transform into dx over x plus 3 over 2 squared plus 27 over 4. Okay, now for this one, we can work it out. We can have 5 over 2 integral. The derivative of x is the same as the derivative of x plus 3 over 2 over x plus 3 over 2 squared plus 27 is the same as 3 square root of 3 over 2 squared. Okay, so this reminds us this integral dx over x squared plus a squared, which is 1 over a, inverse tan of x over a. Okay, so applying here, that means the final solution will be 1 over 2 ln of x squared plus 3x plus 9 plus 5 over 2 times 1 over a. In this case, our a is this expression, so it's the same as 3 square root of 3, which they can cancel out, this 2, so will be 5 over 3 square root of 3 inverse tan of x. Our x is this expression, x plus 3 over 2 over a, and our a is this expression, which is 3 square root of 3 over 2 plus c. So this is the solution of this integral. Okay, so if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.